Right now, deep inside your bones, something is happening. Not on the surface, not where you can feel it, inside a soft, spongy tissue hidden within your largest bones. A process is running, silently, every second of every day. And for most people, it works perfectly. But for some, it begins to go wrong. And by the time anyone notices, it has already been happening for a long time. Most people think of bones as hard, rigid structures. But inside them, especially in the sternum, the hips, and the spine, there is something alive. It is called bone marrow. Think of it as one of the most important factories in your body, running every hour, every day, without a break. Its job? Making blood. Inside this factory, there are master cells. Scientists call them hematopoietic stem cells, blood-forming stem cells. They are rare, and they are powerful. Each one carries the ability to become any type of blood cell the body needs. From these stem cells, 3 essential products are made. Red blood cells, the ones that carry oxygen to every organ in your body. White blood cells, the soldiers of your immune system, designed to find and destroy infection. And platelets, tiny fragments that rush to wounds and seal them shut to stop bleeding. Every single day, your bone marrow produces hundreds of billions of new blood cells. The whole system is precise, controlled, and balanced. But what happens when that balance is broken? Every cell in your body carries DNA, a set of instructions so precise that even a single letter change can alter how a cell behaves. Most of the time, the body catches these mistakes before they cause problems. There are repair systems, checkpoints, and signals designed to destroy damaged cells before they multiply. But not always. Sometimes a blood-forming stem cell develops a change in its DNA, a mutation. And sometimes the body's repair systems miss it. Here is what is important to understand. One mutation alone is rarely enough to cause cancer. Research published in leading journals, including work by Hanahan and Weinberg in Cell, established that cancer is almost always the result of several genetic changes accumulating over time, not a single event. Think of it like a lock with multiple tumblers. One tumbler turning is not enough to open it. But as more DNA changes stack up in the same cell, one affecting growth, another disabling the cell's death signal, another disrupting its maturation, eventually the lock opens. And when it does, something in the marrow begins to shift. In a healthy marrow, every stem cell goes through a maturation process. It starts immature, raw material, and through a precise series of signals, it develops into a fully functional blood cell. Then it is released into the bloodstream to do its job. But in blood cancer, particularly leukemia, something goes wrong in that process. Certain mutations disrupt the signals that tell a cell to mature, so instead of growing up and becoming useful, the cell gets stuck. It stays young. It stays abnormal. And here is the critical part. It does not stop. A normal cell that cannot mature would typically be detected and destroyed. But these abnormal cells have also lost the ability to die on schedule. The signal for programmed cell death, what scientists call apoptosis, has been silenced. So the cell just keeps existing, and it begins to divide. Every time that abnormal cell divides, it creates copies of itself. Each copy carries the same faulty DNA. Each one is stuck in the same immature state. Each one refuses to die. This is what scientists call clonal expansion. One cell becomes 2. 2 become 4. 4 become thousands, then millions. They are not random mutations spread across the marrow. They are all descendants of one original flawed cell, a clone. And a clone has an advantage over healthy cells. it does not follow the rules. Healthy cells divide only when the body signals them to. They mature, they function, they die when they should. The clone does none of that. It simply multiplies, relentlessly. Slowly, the marrow begins to fill. Bone marrow has a finite amount of space, and as the abnormal clone expands, it begins to crowd out everything else. The healthy stem cells that were producing red blood cells, white blood cells, and platelets are being physically displaced. They are running out of room to work. The factory is still full, but most of what it is producing is now defective. Red blood cell production drops. Platelet production drops. The production of functional, mature white blood cells, the ones that can actually fight infection, drops as well. And this is where symptoms begin. The symptoms of blood cancer are not caused by the cancer cells themselves attacking the body. They are caused by the absence of what the body is no longer making. When red blood cells fall, the body is not getting enough oxygen. The result? Fatigue, breathlessness, pale skin. When platelets fall, blood does not clot properly. The result? Bruising easily, bleeding from minor cuts, tiny red dots appearing on the skin. When functional white blood cells fall, the immune system weakens. The result? Frequent infections, fevers, and difficulty recovering from illnesses that normally resolve quickly. These symptoms are not specific to blood cancer. Many conditions can cause them. But when they are persistent, unexplained, and occurring together, they deserve medical attention. Not all blood cancers move at the same speed. In acute leukemia, the abnormal cells multiply rapidly. Symptoms can appear within weeks, and the condition requires urgent medical attention. In chronic leukemia, the process is slower. Abnormal cells accumulate over months or years. Some people have no symptoms at all in the early stages, and the condition is sometimes discovered through a routine blood test for an entirely different reason. Same origin, very different pace. Diagnosing blood cancer requires more than a single test. It usually begins with a complete blood count, a CBC, which measures the number and type of cells in the blood. An abnormal result raises a flag. From there, doctors examine a blood smear under a microscope to look at cell shapes and maturity. If blood cancer is suspected, a bone marrow biopsy is performed, a small sample taken directly from inside the bone to see what is happening at the source. Additional tests, including flow cytometry and genetic analysis, identify the specific type of abnormal cells and the mutations driving them. This matters because different types of blood cancer behave differently and respond to different treatments. Blood cancer is not a sudden event. It is a slow, accumulating process, beginning at the molecular level, long before any symptom appears. Understanding how it starts is not meant to cause fear. It is meant to create awareness. If you or someone you know has been experiencing persistent, unexplained fatigue, repeated infections, unusual bruising, or other symptoms that will not go away, please speak with a doctor. The earlier blood disorders are identified, the more options exist. Your bone marrow works invisibly, every day, to keep you alive. Pay attention when it asks for help.